Hello world, my name is Data Mining Mike. In today's video, we're gonna go into exploring YouTube video engagement metrics. What is engagement per view? And how does it matter? Why does it matter? And how I'm gonna use it to show you the best categories. And also, we're gonna really quick go over what trending tags I can find. So I mined over 1 million rows, 1 million rows, but for this video only, I'm just gonna do the US. But in this, I ran a Shapiro wheel for YouTube video engagement metrics using an exploratory data analysis. Whatever the fuck that means. Look, this is run in Python and Jupyter notebooks. First thing I did in this first cell is I imported pandas, NumPy, Seaborn, and Matplotlib. I need pandas, why? Because this is a massive data set and I can't manipulate these data sets on Excel. Therefore, thus the purpose of big data is any sort of data set that is too big to actually be manipulated on Excel. That's my definition of big data. There's a lot of definitions running around out there. Either way, Seaborn for the visualizations, Matplotlib as well for visualizations. I import the data set and let it compile. Voila, here we go, inspect the head. And so this head function allows me to see all the columns and column names. So I have video ID, title, published date, all the way to other redundant crap like rating disabled and description. So a lot of these I'm not gonna need. So, and a lot of this data is dirty, so I have to clean it out. So the first thing I do is I inspect the data types. So I see what's an integer and what's an object, and that's sort of a nerdy computer science thing. The next thing I move on to is the shape. I inspect the shape. And then I drop all the missing values and I re-inspect the shape again, and it's 2.1% sparse. That's not that bad. This is a fairly clean data set to begin with because it was a good API pull from this guy, basically an angel. I mean, he's spending a lot of money to pull all these rows of data, okay? Because all these API pulls cost money and they're only pulling like 50 per request. But either way, when I run these descriptive statistics, if I can speak right, I see that the average number of views for a trending video is 2 million. The average number of likes is 127K and dislikes is about 1.5K. And I moved down to Univariate Exploration. What is Univariate Exploration? Univariate Exploration is where you explore one variable at a time. One variable at a time. So what you're gonna see as I explore the variables of views, likes, dislikes, comment count is there is gonna be this tiered structure, as you can see here, because I'm just plotting out view count. So as I plot view count, you're gonna see it's this tier structure of virality that the algorithm is using in order to determine and make better predictions as to what the audience might like to see and what will trend. What you're not seeing is a reflection of viewer behavior, but more so a tiered system as to how the algorithm is gonna make a prediction. So if we look here, most of some of these videos here that are less than 10,000 views, there's a lot of videos that went viral or trended that had less than 10,000 views, all right? However, if your video is to reach up to the next tier, then the next tier, then the next tier, then the next tier, it can start making predictions. And we're gonna see this tier system and how they almost line up exactly as we go through this. And I also do a test to see if these tier systems line up exactly. And then here we have something that's unique with YouTube is the dislikes. So the dislikes is a double-edged sword because the dislikes have the ability to kill a video's trend for the fight against outrage culture and as a failsafe for the audience in the event that some sort of malicious content got past the YouTube screening algorithms and got in front of the audience. Therefore, the audience can hit the dislike button and just kill the video completely. However, it can also be weaponized for networks, against other people, or against other networks. Either way, that's something to be considered. But one thing that this graph can show me, along with all these other univariate graphs, is that there's not many more dislikes past this almost around 90,000 mark, all right? So therefore, if the dislikes aren't gonna kill the video within the 10,000 view mark, it's most likely gonna survive no matter how many dislikes you get past that, according to this data and according to the graph. Okay, but next thing, I move on, I created this key performance indicator, or KPI, as all the cool kids like to say. And what it is it's a featured engineer. So, or I'm sorry, engineered feature. I engineered engagement per view by taking the total view count, then dividing it by the sum of likes plus dislikes plus comment count. And that gave me this engagement per view. So when I plot an EPV, it has one distinct mode. One distinct mode. And now, this is an important test, the Shapiro-Wilk test. So the Shapiro-Wilk test is gonna gauge for normality. So it's gonna gauge, hey, is this variable, does it fall on a bell-shaped curve, or does it have some sort of a skewed curve, all right? So what I did was I took this metric, EPV, and I ran it through Shapiro-Wilk. And turns out, it tested completely positive, a 1.0, for being Gaussian. Okay, therefore it is a very distinct, deliberate, bell-shaped curve plotted in the system to manipulate engagement, and I'm gonna prove it. Now, when I individually tested the groups of likes, dislikes, comment count, they all were negative, so they are not all within the same grouping distribution. And that's kind of obvious to tell too. With these graphs, the univariate graphs, it's kind of like they're in the same distribution, but not quite. I think if anything, these are more representative of like tiered virality milestones. However, moving on to the Kruskal-Wallis test. The Kruskal-Wallis test is a really important statistical test to compare the differences between groups of data. So, once again, I'm trying to compare the differences between likes, dislikes, comment count, and I do that. And I compare all these groups, and they're all different. They all come from different distributions of data. They don't all come from the same data distribution. That's what it means. So, however, it appears to be in the univariate graph kind of tiered. But moving on, when I do bivariate, so that means two variables at the same time being compared against each other, that's gonna explore and open up a lot of different things that's really cool. For example, when I do video categories that get the most views, I see that category 10 and then 15 through almost like 28, 29, but that's not very descriptive. So when I plot just category ID against the view count, what I get is category ID 10, which is music videos, has the highest view count of all the other ones. However, when I inspect engagement per view directly against category ID, I get this beautiful bell-shaped curve over 27, 28, 29, which is how-to, education, and science and technology. And next, I'm gonna explore, look at this graph right here. So this graph right here shows the frequency count of the number of videos per category. So we can tell that gaming, entertainment, and music are in the top 3. They're in the top 3, however, we know that it's how-to, education, and science and tech that are within the bell-shaped curve. Therefore, the algorithm is going to favor these 3 and give them positive engagement per view, just by precedence. So, next thing I do is I use this thing called word cloud and I go through all the trending words. So I want you to watch these trending words. Be sure to like, subscribe, and smash the bell for more data-driven updates. Why should you subscribe? Because I gave you value. Because I give you more value. Look at that. League Sport Highlight NBA Game Basketball. Trending tags for how to, makeup recipe, food. You can pause this video at any time. Go ahead and write these down, but these will also be available in other shorts that I make that I distribute on the channel as well. I data mine these tags quarterly for you. Look at that. Unboxing the new Apple iPhone. It's a Pro Tech review, 2023. All right, guys, thank you. Once again, my name is Data Mining Mike. Be sure to like, subscribe, and smash that bell for more data-driven updates. Bam!